Today I'll be talking about something very important in operating system, that is system calls. Whether you are writing programs or working with Linux or just curious about how things work behind the scenes in on computers, system calls is an must know topic. Let's get into the topic. First, what are system calls? Alright. So, what exactly system calls? Think of them like a middleman between your programs and the operating system. If a program wants to do something like open a file, create a process, or even talk to hardware, it can directly access the OS. Instead, it has to request help through the system calls. Next, why are system calls is needed? Why can't programs directly or access hardware or OS features? It is very simple. Security and control is the main reason. If every program had direct access, one bad program could crash your entire system. System calls make sure that only safe and authorized actions to happen. What are the types of system calls? There are mainly five types of system calls are there. Process control, file management, device management, information maintenance, and communication. These covers almost everything your OS does. Next, process control system calls. In OS, every running task is a process. These system calls help to manage them. Fork, for example, fork is used to create a new process just like a photocopy of the current one. Exec is used for execution. Exit is used for stopping a process. Wait is used for makes a process wait until the another to finish. All multitasking in OS depends on these calls. Next, file management system calls. File handling is a core part of computing. These system calls do the job. Open is used for opening a file, read is used for reading a content in a file, write is used for save the content to a file, close is used for closing the file. Without these, we wouldn't have any documents, code, or even our favorite movies. Next, device management system calls. When you connect a printer, USB, or even a keyboard, the OS needs to manage it. That's where these calls come in. IOCTL. It is used for sending special instruction to the devices. Next, read or write. They are used to interact with the devices to transfer data. Basically, these calls make sure your devices and the OS talk to each other smoothly. Next, information maintenance system calls. Sometimes a program need info about itself or the system. This helps get PID. This is used for finding the process ID. Alarm. It is used for setting a timer for something to happen. Sleep is used for pauses and execution for a few minutes or for a while. They are mostly used for system monitoring and automations. Communication system calls. Have you ever wondered how WhatsApp, Zoom, or even multiplayer games works? That's inter-process communication. Some calls that make this happen. For example, pipe. Pipe is used for creating a private connection between processes. Next, SHMGET is used for allocating shared memory. Next, send or receive. It is used for sending and receiving messages. Without these, no app could talk to another. Next, let's see system call versus library functions. People often confuse system calls with the library function. Then what is the difference between them? System calls directly talk to the OS to the kernel. Library function like printf uses system calls, but they also add some extra functionally. For example, printf ultimately calls write to send the data to the screen. Next, how system calls works. Let's say a program wants to read a file. Here's what happens. First, it calls read. Then, the OS traps the request and switches to kernel mode. Next, the OS reads the data and sends it back. Finally, the program gets the data and continues running. This transition between user mode and kernel mode ensures security and stability. Next, user mode versus kernel mode. In user mode, apps have limited access to the system. If they need something special, they must request kernel mode using system calls. Using user mode, it is safe but restricted. But kernel mode provides full power but dangerous if misused. This is why OS security is so strict. Next, Linux system calls. In Linux, everything is a file, even devices. Common system calls include read, write, open, close for file handling, and fork, execute, wait for process control, and socket, bind, listen for networking. Linux relies heavily on system calls. Next, Windows system calls. Windows does things a bit differently. Some Windows system calls are nt create file. It is used for creating a file. Nt read file. It is used for reading a file. Nt write file is used for writing a file. Write to a file. Windows provides the Win API, which makes working with system calls easier. Next, common Unix system calls. Unix-like systems use system calls like fork, execute, kill, wait. Fork is used for creating a child process. Execute is used for replacing a process with another program. Kill is used for terminating a process. Wait is used for making a parent process wait for a child. If you have worked with Linux, you have definitely used this. Next, system call interface. The system call in the interface is like a translator. It converts system calls into instructions, the, the instructions can be understood by the OS. This ensures different OS versions stay compatible while maintaining security. Next, system calls and performance. System calls are slowly compared to normal function calls because they involve mode switching and extra validations. Mode switching is used for going from user mode to kernel mode. Extra validation represents security checks and access controls. Too many system calls in a program can slow things down. Security concerns in system calls. System calls are powerful but also risky. If misused, some common security risks are privilege escalations, hackers gaining admin rights, buffer overflow, corrupting memory to crash or control a system, system call hooking, modifying system behavior for malicious purposes. Good security measures like validation and permissions are a must. Next, system call optimization techniques. How to make system calls more efficient by reducing calls. Don't make unnecessary requests. Batch operations. Send multiple requests at once. Caching. Store frequently used data instead of calling the system every time. This improves performance in high speed applications. And now we are at the end. Summary of Key takeaways. Alright, quick recap. System calls let user programs talk to the OS. They handle processors, files, device, and communication. They work via user mode and kernel mode transition. Security and performance optimizations are important. Understanding system calls helps us to write better and safer programs. That's all. Now we are at the end of the video. Thank you.